Okay, can I interrupt you now, please, so that we can look at moles and chemical equations? And this is on page 33 in your booklets. And the equation that's in the booklet is this one here. It's already been balanced, so we know that we balance chemical equations with these coefficients out the front. We can't balance with the little numbers because those little numbers, the subscripts, talk about what the ratio is within the compound. And so if we change those numbers, we would change the compound that we're either reacting with or producing. And so for our chemical quantities, these coefficients are very important for us to be able to work out either how much a reactant we might need or how much product we could produce. Because this is saying, in this case, 4 atoms of phosphorus will react with 5 molecules of oxygen to produce 2 molecules of diphosphorus pentoxide. It could also mean, now that we know about moles, that 4 moles of phosphorus atoms plus 5 moles of oxygen molecules will react to produce 2 moles of diphosphorus pentoxide. And because we are now knowing how many we have, it does mean that we can do these calculations as far as masses are concerned. Because if we know the atomic masses of each of the elements involved, we can convert these balanced equations into chemical masses that we could use in the lab. So how do we go about doing it, and what do the questions look like? Well, to start with, it's a simple kind of thing of let's just look at the mole ratio. Our first question is, how many moles of oxygen are needed to react with 3 moles of aluminium to form aluminium oxide? So we're going to have some aluminium, and we're reacting it with oxygen. Now it must be O2 because it's the oxygen gas that occurs naturally in the environment. And we're producing aluminium oxide. The aluminium oxide formula was given in the question, but you should be able to figure out how to write aluminium oxide now. How would you do that? What do you need to know? Yeah, we would need to know the charges on the ions, because what kind of bonding is present? It's ionic bonding. Why is it ionic bonding? We've got a metal and a non-metal. If I wasn't sure if aluminium was a metal, how would I find out?
It was on the left side of the periodic table.
It's on the left side of that heavy line on the periodic table. It's a metal. That's right. So it's ionic bonding, metal plus non-metal. I would look on my table of ions, and I would see that aluminium forms a 3+ ion, and oxygen forms a 2- ion. And so that would mean that to balance the charges, I would need to have 2 aluminium atoms for every, or ions for every 3 oxide ions. Does that make sense? Yeah, okay. So what we're trying to do with we're bringing some of our bonding with us. We're using that information that we already have learned to help us with our chemistry. So this is not balanced. Best to start with these odd numbers. If I put a 2 out the front here, then I've got 6 oxygens on my product side. And I could put a 3 in front here, and that would balance the oxygens. And if I look now at my aluminiums, I think this is pretty easy. I just need to put a 4 out the front there that's balanced. The solid reacting with the gas is going to produce a solid. I can put in my states. We're told we have 3 moles of aluminium. And we're asked to work out how many moles of oxygen are needed to react with, yes, that's right. We want to know how many moles of oxygen we need if we're going to completely react 3 moles. Well, we would, if it said 4 moles, it'd be pretty easy, wouldn't it? We could just say straight up, oh, well, we're going to need 3 moles of oxygen gas. So we just need to figure out, well, what are we going to be doing here is using the coefficients in front of those two. The one we know and the one we're finding. What we're finding divided by what we have as far as our coefficients are concerned, we're actually going to need 3/4 of 3 moles. So if we find 3/4 of 3, we'll just see that that's 2.3 moles of oxygen gas required. Is that sort of okay? Anyone got any questions? We could also work out how many moles of aluminium oxide we produced was. Same thing. We want this 2 divided by the 4. Again, we're going to use the 4 because that's what was given in the question. And so then that would be 1.5 moles. Now that wasn't asked for, but hopefully you can see that this makes sense. That 2 is half of 4. And so we're going to end up with half of the number of moles of aluminium that we were given in the beginning of the question. If sometimes people get these ratios around the wrong way, just double check, does this make sense? Because if I had these round the wrong way, this would tell me that I made 6 moles of aluminium oxide, and that wouldn't make sense if I'm looking at the quantities. And so you can double check the maths and make sure that it makes sense. There's a couple of try it yourselves on page 33 that I'd like you to do. And then we'll look at the mass calculations after that.